Hello everyone. Today we are going to create a linear standard curve for your experiment in Excel. And for that, I have written some data over here that I have taken from one of my personal experiments. I took a polymer and made some standard formulations in milligram per ml. These standard formulations were then observed at certain absorbance values. This is 333 in my case, and these are the absorbing values. Now you can see each formulation has shown some absorbance values, but in the end I have written another absorbance value that is without any formulation because here I did not use any standard. Now this proves experiment has some sort of background error. It is very important that before creating your graph or standard linear curve, your absorbance values must be background corrected. And how do you do that? Just simply click is equals to sign here and click on the column from which you want to minus or subtract this error value. Then click on the subtraction sign and finally the column which you want to subtract. Here I'm going to give you a simple tip that you need to write the dollar sign before and after the column. What it will do, by writing these dollar signs, whatever the command you are going to give here in the Excel, it will not affect this column by itself. How? You can see later. Just simply click enter here and you can see this 0.009 is being subtracted successfully from this first absorbing value. Now if you just click here and keep dragging below, you can see each value has been background corrected, and in the last 0.009 is being also subtracted from the same value. And if you got the 0, means that was not being affected by the whatever the command I gave here. Now your values are being background corrected. You need to move further to make your graph. These are the values that are supposed to be selected. Take. Now you select these values and go here, insert, and click on the charts. Click on the scattered chart. Some edits are supposed to be made here, and how do you do that? First select the chart title and just simply delete here. Add this chart elements, you need to add the axis titles and you are supposed to edit according to the data that you have. Then again click on the chart elements and select the trend line. Now this trend line proves whether your experiment is acceptable or not. How? You can confirm it by having the equation on the chart. And how do you do that? Just okay. Simply click on any of the dot here and format trend line. You can see certain options here. Already the linear trend line is being set here. Now you're supposed to display the equation on the chart and also with the R squared value. Now this is the equation on the chart which you will use further for finding the absorbance values or the concentrations, sorry, the concentration. But what does the R square value means? Now it has if okay, I'm simply going to explain it here. How? Means the R value, if it is below 1, it indicates that the standard curve is not a perfect linear fit. While if the R value is exactly 1, it means all the data points fall perfectly on a straight line. But on the other hand, a lower value indicates some degree of deviation, experimental error, or non-linear relationship. But in your experiment, how do you consider it? Let me explain in much easier way. If your R value, where is the sign? Sorry, I'm going to find it. Yes, okay. Sorry, I just could not find the sign over here. Okay, just simply right here. If your R value is less than 1 and is closer to 0.99, that means your data is excellent, or you can say it is ideal. Means the standard curve is highly accurate and suitable for the precise quantification. Secondly, if your R value is between 0.95 to 0.99, that means your data is either good or acceptable. In many fields, this is acceptable for routine experiments, but it indicates some small variation or potential inconsistency in the pipetting. Now, finally, if your R value is below 0.95, then it indicates poor and unacceptable results. Means the curve shows significant variation, that is scattered in points. Means the data points do not follow a straight tight linear trend. It indicates the potential error in the concentration preparation or the instrumental issues. So in the end, you have to accept the first one, that is closer to 0.099. That will be considered as the excellent or ideal data. Thank you for watching the video, and if you have any query, please do not hesitate to ask. Thanks for watching again.